Okay, in this section we are going to talk about section 2.5, the last section of chapter 2. So let's talk about that. It's going to be section 2.5. This is the marginal cost and revenue. Marginal cost and revenue. Okay, so when you talk about the cost and the revenue, the cost is the money that you spend to make a product, right? That means if you want to make something to sell to people, the money that you invest to your company is the cost to make the products. The revenue is the money that when you sell the product and you get from the customer. Okay. Now we are interested in the marginal cost and the revenue in this section. So basically, if you make, for example, if you make 10 products and now you want to think that if you should make another product, the 11th product to sell for the customer. So we don't know what if we will lose more money or we will make more money after we make more products, and those money that we get or we lose from making one more product is called the marginal cost and the revenue. That is the cost at the margin or the revenue at the margin. Now take a look at this this graph. I have Q represent for the quantity and C for the cost. And remember, the y-intercept is the fixed cost, right? So even if you do not sell, this is 0. So even if you sell 0 quantity, you still have some cost at the beginning. It's called a fixed cost. This could be the cost to build a machine, to buy material, something like that. So even if you don't sell any item, even if you don't make any item yet, you still have the fixed cost, like the renting, monthly rent for your location, something like that. Now, if you take a look at this graph, as we increase the quantity or we produce more product, we also spend more money, right? Because if you spend more, if you make more product, you have to spend more money. And this line is the linear line. That means we have a constant slope. That means if you go from the left to the right, the rate of change is constant. So if you take the slope at this point and slope from this point to this point, they are the same. So that's what is called the linear or constant slope. Comparing to the other graph, I also have Q representing for the quantity and C for the cost. But now I also have some fixed cost. But now the curve is not a linear anymore. It has a shape of concave down and then concave up. That means at this point it takes some money to make the product, and the price gets increased faster around this area, then it's slowing down around this area, and then it's going steeper in this region. So it's not constant for the whole time. Comparing to this one, we call it a linear because it's all constant for the whole period of time. But for this one, it's increasing and then going down and then increasing again. So this is a non-linear case for the cost function. So if you look at the graph, make sure you can identify which one had a constant rate of change, which one doesn't have a constant rate of change. And the formula for the revenue, we use the letter R, big letter R for the revenue. So revenue is the money that you get for selling a product. So it will be proportional to the price and the quantity, right? So Q represents for the number of the items. B is for the price. So if you have the price like $10, if you sell 5 items, 5 times 10 give you 50. If you sell 10 items, it's gonna give you the revenue of $100. So B is the price. Q is the quantity. Right. Now, if I graph this one on the XY plan, I also have something very similar to the above graph. So, but here we don't have the fixed cost or the y-intercept in this case, because if you have 0 quantity, that means you don't sell anything. If you don't sell anything, your revenue should be 0, so it should be at the origin. Now, as you sell more product, your revenue is increasing. In this case, we have a constant or the linear revenue curve. And the other case, we have something called a non-linear curve. That means it's not a straight line, right? So at the beginning, you also have 0 and 0 for nothing for the revenue. Now, we have the linear around this area. But then somehow, in this area, the rate of change is smaller than this area, because as you sell more products, later on when you sell more product in a large quantity, the product price tend to be getting smaller, right? At the beginning, if you sell just 1 or 2 items, you have the better price. But if you sell for the customer with 1,000 units, 1,000 items, you have to decrease the price a little bit for the large amount of items. So that's why we get something smaller for the rate of change for this case. Okay, now we know what is the revenue curve, the cost. Let's go with one example. I have one example here, and this straight line represents for the revenue curve, and this curve here is for the cost. Now this point is 130. This is the quantity, and this point is 215, and this is the money. Okay, so they are asking what quantity the firm makes some profits. Okay, so ask what quantity, how many units did the firm make the profits. So remember, we have a profit. That means we make more money whenever our revenue is bigger than the cost that we produce the item. So this is the cost that we have to produce the item. This is the revenue when we sell the item. So we make the profits whenever the revenue is bigger than the cost. If we look at this curve, revenue is the straight line, right? Straight line. And in this region, in this area, the cost is bigger than the revenue. But in this area, the curve straight line, the revenue is bigger than C. So we can conclude that from 130 to 215. So if we have the quantity bigger than 130 and less than 215, in this amount of items, we make the profits. Okay, now let's move on to the marginal analysis. Okay, so remember the cost and the revenue as the margin equal to the additional revenue and the cost. So the cost and the revenue at the margin. This is the same thing as additional revenue plus the cost. So at the margin, as I told you earlier, if I had 10 items, right, and I want to see what if I make one more item, should we do that or should we not do it? If we make a profit, then we should produce that additional item. Now, the additional item, we also have the additional cost for making that item and the additional revenue for making that item. So the additional revenue and the additional cost, we call that the cost at the margin and the revenue at the margin. That means the cost at the margin is the cost for making one more item, and the revenue at the margin is the money that we get for selling one additional item. Now take a look at this example. Hopefully it will make sense. I have the function, the cost function, right? This is the cost of the flies. Okay, now we know that originally we have 100 flies, okay, and this means the number of flies is a Q, the item. So we have C of 100. This is the cost for 100 flies of that company. Now, if we make one more additional fly, we have something called the additional cost, or the cost as the margin. That means the cost of one more fly, we have to take the cost as the 101, which is one more, subtract the cost at 100 fly from the original flies. So subtract these two, we got the additional cost for having one more flies to the system. And the average rate of change of the second line. Remember, the second line we need 2 points. So we have this point for the 101 fly and the other points for the 100. So if you take the rate of change, you're going to take the output minus the change in the output, C101 minus C100 divided by 101 minus 100. So this is the slope of the second line for the additional cost. So now we can define the marginal cost to be MC marginal cost, right? This one is basically the instantaneous rate of change or the derivative. Q is the fly with respect to Q. Basically, you just gonna take the one more extra, right? You subtract from the original one. So just take the difference between the two. Like in the previous slide, we take 101, C101 minus C100. So we take one additional item units, subtract from the original one. That's why we got the marginal cost, or this is the slope of the cost curve. So basically, the marginal cost is the slope of the cost curve as the point Q. Now, if we take a look at this one, I have 100 fly right here and 101 maybe here. So if I have something like this, right, this is 101. If I connect the 2 points, I have the slope. Now this is the slope of the second line, right? This is C of 101 minus C of 100. Now, if I do the tangent line at the point 100, this is the tangent line or the derivative at the point 100. You see the two curves when it's getting very close together here, it's basically the instantaneous rate of change at the point 100, or the slope of the cost curve is basically the marginal cost. The same thing to additional revenue. Okay, at the margin. If you take the revenue for the 101 fly, right, you subtract from the original 100, we get the revenue for one extra fly. Now we define the marginal revenue to be MR marginal revenue. This is basically the slope or the rate of change or the derivative as Q of the revenue function. And if you can estimate that, just take the one above that, the additional one, minus the one from originally the original value. Okay. Okay, so let's go to one more example. I have the first curve is called a cost curve, right? And then the second curve is the revenue curve. So it will depend on the quantity. Okay. Now we have this point and this point. Okay. If I draw the tangent line here, I got this is the slope of the marginal revenue. This curve is for the revenue curve. So if I draw the tangent line here, I got the slope of the marginal revenue. This is the cost curve. If I draw the tangent line here, I got the slope for the marginal cost. Now imagine this point is the fly 101, the additional 101. Now, should the company add that additional fly to the system to make it to have it for the 101 fly? Should we make it or no? We only add one more product if we think we can make the profits. Now, if this point represents for the quantity or the fly of 101, if you check the slope, which is the marginal cost or the marginal revenue of the two curves, you see here the slope for the revenue here is steeper comparing to the slope of the cost is much smaller comparing to this one. This one is more steeper. So we can see that the slope of this one or the marginal revenue is much steeper comparing to the slope of the cost curve or the marginal cost. So the marginal revenue is now bigger than the marginal cost. That means when we add one more additional fly, we got the revenue should be bigger than the cost. Then we have to say yes. Okay, another example. I have another graph here. 1, 2, 3, 4. 1, 2, 3, 4. This is Q. The quantity. This is in thousand. Okay, and this is in money. So if I draw the graph here, okay, here is $10,000. Here maybe $20,000. Okay. Now we want to compare when we are at 500 product and 2,000 product. which ones will produce higher profits or making more profits. And also for the case of 3,000 item versus 4,000. So which one should make a profit? So the company should decide if we make with this particular amount of item or this one. Now, one here is represent 4,000 to 1,000. So 500 is around here. So this is 500. So 500, if we draw the point to here and we draw the slope, we got this slope. Now 2,000 is this one. So we draw to this point here, we draw the slope. Okay, you see this slope is steeper compared to this one. This one is almost horizontal or zero, but this one is more steeper. So we know that this function is the cost function. We know that the cost for making the 500 product is much more money comparing to the cost for making 2,000 product, because the slope at the 500 is much higher compared to the slope at 2,000 product. Now for the case of 3,000, this is 3,000. So let's compare the slope. If you draw the slope here, the tangent line, you got something like this. And if you draw the slope at 4,000, you got something like this. So you see, this one is not steeper compared to this one. So we know 4,000. The cost is growing faster. Okay. And another question that they ask is that what production is the marginal cost smaller, and we want to find the total cost as this level. Okay, so you see, if we want the marginal cost to be smaller, that means we want the slope of the cost curve to be small as possible. So if we compare on all of this curve, we see that around 2, the slope of the cost curve is very small. It's almost flat or zero. So we know that the slope is around 0 as the quantity equal to 2,000 unit. Okay, and at everywhere is positive and growing. So we should pick around this point for the marginal cost to be smallest. Now, what is the value at this one? The value, that means we're asking for the cost when we're producing 2,000 units. So we have approximately 10,000. So it's take around $10,000 to make the product at the level of 2,000 units. Okay. So that is the example. We have one more that we have finished for this section. Okay. So now I will give you guys 1 point extra credit to your first exam if you watch the video to for this section, and if you watch it, so you know what I'm saying, that I give you 1 point for the first midterm exam. So email me saying that you heard what I say in the video for getting 1 extra credit when you guys watch the video. So you have to email me before the class on Tuesday at 8 a.m. Okay, if you email me before that on Tuesday before the class starts, then I'll give you 1 point for the extra credit toward your first midterm. Now let's move on to the final example. Then we are done for this section. Okay, now I have 2 curves. This is the money, this is the quantity, this is the revenue, and this is the cost, right? Quantity money to the quantity 100. Now we are given a curve for the revenue for the cost function, and we are asking to sketch the marginal revenue and the marginal cost curve. Remember, the revenue is what? Is the price multiplied for the quantity, right? Which is represented by this curve. Remember, for any linear curve, the one that's standing in front here is a slope, right? Or the price is a slope. So this one is a slope for the linear curve, and the marginal revenue is basically just the slope or the derivative of this function, which is just the slope, the rate of change, or P, or the price. So any price you have here, let's pick 2 points. If you find the slope, that's going to be your price or your marginal revenue. So the MR, or marginal revenue, in this case it's just P, a constant P for the price. It can be anything, but it must be a constant one. So we can sketch this easily, right? We have Q, we have the money per unit. Slope is the money per unit. So P is any constant, so I can just say P is maybe this constant, and this is AMR, because it's just a single constant, so it's just a horizontal line at the P constant. So that's easy for the case of the revenue. Now for the case of the cost, so remember here we always see that there's some slope around this area, and then one more slope around this area. They are different, and then another slope around this area. So for this case, it's all constant, just one value. But for this cost function, it's changing, right? So we cannot just have one value and then draw the horizontal line for this case. That's not work for this case. We know that for small value, small quantity. So if you look at the graph, when you have a small quantity, for example, less than 100, the graph seems to be concave down, right? Concave down. And if it's concave down, then your marginal cost or the slope should be decreasing. Now for large Q, I say maybe something bigger than 100, right? We divide that region into two cases. For small Q below 100, we have concave down, or the MC or the slope decreasing. This is the marginal cost. Now for large Q, we have something, it looks like concave up. So we have concave up in this case, or the slope or the marginal cost increasing. Okay, so we have decreasing in one region and increasing at another region. So first we decreasing, then we increasing. That means we have to go to a one minimum point. And so I can draw the MC curve. This is money per unit as in this graph. So this is MC, this is 100. Remember, 100 is here. Remember, below this we are decreasing. That means we go down to 100. We concave up. That means we increase the graph, or we go up from here. So we decrease, we concave down from in this region, right? We decrease, and then from here 100, we concave up from here. That means we increase the graph, so we go up to here. That means that's 100 point here. The graph has a minimum value, the mean value. So we go down and we go up. So this is the general curve for the MC, and this is the general curve for the MR from the given curve of revenue and the cost. So basically this is the end of section 2.5.